This video is a series of questions to help you understand how pressure changes with the depth in a fluid and how to use that information to calculate the upthrust on an object. So we have three questions here, 1, 2 and 3. Each one will have several parts, A, B, C, D, E, F and G. We'll start with A. Find the depth of the top of the cube, and B. Find the depth at the bottom of the cube. Pause the video now to attempt to do this. Next, cube 1. The cube is submersed in water, which has a density of 1000 kilograms per meter cubed, on Earth with a gravitational field strength of 9.8 newtons per kilogram. Use the equation pressure equals density times gravitational field strength times by depth in the fluid. To C, calculate the pressure at the top of the object, and D, calculate the pressure at the bottom of the object. Now I'll show you the solution in the next slide, but if you want to attempt to do this yourself, pause now. So to calculate this, all we need to do is use that equation and replace the symbols with the numbers relevant. So we have rho, which is the density. We know that the density of water is 1000 kilograms per meter cubed, so we replace rho with 1000. We know that gravitational field strength is 9.8. So we replace G with 9.8, and finally the depth of the top of the cube was 12 meters. We multiply these numbers together to find that the pressure on the top side of the cube is 117,600 pascals. We do the same for the bottom of the cube, and we find that the pressure at the bottom is 127,400 pascals. Now attempt to do the same for cube 2. This time it's submersed in a liquid of density 900 kilograms per meter cubed, but it is still on Earth. Pause the video now. And now attempt cube 3. The next stage is to use this in order to determine what the force on the top of the cube is and what the force on the bottom of the cube is. So using the equation pressure equals force per unit area and your calculation for pressure at the top of the cube, calculate the force caused by the water pressure at the top of the cube. And then similarly, calculate the force caused by the water pressure at the bottom of the cube. Since this is a cube, we know that all sides are the same length, so therefore it will be an area of 1 meter squared. The solution is as follows. Pressure equals force over area, so we've got 117,600 equals force divided by the 1 meter squared, which is the top side of the cube, and that gives us 117,600 newtons. Meanwhile, at the bottom of the cube, follow the same calculation, and we find that it's 127,400 newtons at the bottom of the cube. Now attempt to do the same for question 2. And finally for question 3. The final step is to find the upthrust. Now the upthrust will simply be the difference in the force from the top of the cube and the bottom of the cube. So to find this resultant force in this particular case, we have the force at the bottom minus the force at the top. This gives us a resultant force, so an upthrust of 9,800 newtons. Attempt to do the same for cube 2. And now attempt to do the same for cube 3. The next stage is to look at the same cube at different depths in the fluid. So a cube of side 2 meters is submersed in water which has a density of 1000 kilograms per meter cubed on Earth with a gravitational field strength of 9.8 newtons per kilogram. Using the equations, pressure equals density of the fluid times by the gravitational field strength times by the depth in that fluid, and pressure equals force per unit area, find the upthrust on the object. Attempt to do this now for cube 4, 5 and 6. These are identical cubes. Finally, you may have noticed something about your answer. This can simplify the problem for you. So, without being given the depth of the object in the fluid, I want you to now calculate the upthrust on this object.